Snell's law. This is still refraction. And Snell's law, I love the name, Snell. I want to say Schnell, like German, but it's Snell. Not snail, not smell, not Schnell, but Snell. Snell's law. And Snell's law relates the angles of when things refract, when light refracts, the angle of incidence to the angle of refraction. All right, always measured to the normal, not to the surface. Be careful with that. So let's say that we have, I don't know, diamond. Woo! And the index for diamond is about 2.42. The index for air, remember, is roughly 1. And what is the angle measured to the normal and to the surface? So if this is so I have an incident light ray at 60 degrees to the normal, which means it was coming in at 30 degrees to the surface of the diamond, the air diamond boundary. All right, because those have to add up to 90, right? Well, when it goes into diamond, because diamond is obviously more dense than air, it's going to bend, what we say, bend towards the normal. It's going to be a tighter angle. When it goes into something less dense, it bends away, but there's nothing going to be less dense than the air except for a vacuum. So when it bends into the diamond, it's going to, same color. It's still the same color. It hasn't changed frequency, remember, it just changes speed and wavelength. It's going to bend there, it's going to be a tighter angle. It spins towards the normal. And let's find that angle in the diamond. Okay, theta d, d for diamond. Well, Snell's law is pretty simple. You have to use your calculator. You have to use sines. So be sure, and we're going to use angles. We're using degrees. So be sure you're in degree mode, not radian mode, because these angles are in degrees, not radians. And Snell's law is simply this: the index in one medium times the sine of the angle in that one medium, again, this is measured to the normal, is equal to the index in the other medium times the sine of the angle in the other medium, measured to the normal. So in this case, we have air and diamond. So the index for air is 1, and the sine of the angle to the normal is 60 degrees. The index for diamond is 2.42. And that allows us to find the angle in the diamond. All right, I'm going to put a D here for diamond. So I'll solve for the sine of the angle first, and then I'll do the inverse sine, the arc sine, the inverse sine to find the angle itself. In the lab that you're going to be doing after this, I'll probably assign that the next day. You are going to measure the angles. The air is an index of 1. That's a given. So that's a given. These angles you can measure with a protractor, and then you can calculate the index for various substances. And it's just a lab activity that we're going to be doing in our next lesson. So anyhow, let's solve for this. The sine of the angle in diamond is going to be, let me get my calculator going here. Let me see here. It's giving us the sine of 1 times the sine of 60 divided by 2.42 is 0.358 rounded. 0.358, but remember that's not the actual answer. I don't want the sine, I want the actual angle. So the angle is going to be the inverse sine, arc sine of 0.358. So on my calculator, that second function sine of the answer there, which is 20.9, it's 21 degrees. Okay, 21 degrees. So this angle right here is 21 degrees to the normal, which means that the angle to the surface is 90 minus 21, which is what, 69 degrees, I think? Yeah. Okay. That's essentially it. That's the basics for refraction. Okay. And you have homework using Snell's law for tonight, and then tomorrow's activity is going to be a lab. I've done the lab for you, and the purpose of the lab again is to find the indices of refraction for 4 different substances. All right, I've done it, and you're going to take the data and write a lab report on it. But that's for the next class period. Okay, miss you. Again, it's so lonely around here. There's nobody there. I'm here. But, Okay, bye everybody. I really do miss you all. God bless you. Take care of yourselves.